Hey guys, happy Wednesday. Today we're going to be talking about rectangles with fractional side lengths. Our learning target for today says, I can multiply mixed numbers to find the area of rectangles with fractional side lengths. I can confirm areas by tiling with squares of unit fraction side lengths. So we're going to find the area of rectangles that have fractional side lengths using two methods. For the warm-up today, we're going to complete this in our Google Hangout later this afternoon. So I'm going to skip through this. If you want to go ahead and look at these questions ahead of time so you have an idea of what to answer later, that would be a good idea. You can always go back and look at the slides on your own. For the math message today, solve problem 1 on Math Journal page 240. That's in volume 2. Think about what strategy you chose to use. If you want to pause the video at this time so that you can have time to complete that, go ahead and pause it now. What strategy did you use to solve the math message? We were supposed to find the area of the rectangle, and we're going to report our answer in square feet. Anytime you find area, you should be reporting your answer in square units. Here are some strategies that you might want to use. You could use the formula for area of length times width and multiply 8.5 by 5.5 using partial products. 8 times 5 is 40, then 8 times 1/2 is 4, then 1/2 times 5 is 2.5, then 1/2 times 1/2 is 1/4. Then after you add those partial products, you get an area of 46 3/4 feet squared. Remember, you could also change your mixed numbers to improper fractions and then multiply straight across and divide to get your mixed number. That's shown here. Multiply 8.5 by 5.5 by renaming the factors as fractions. 8.5 is the same as 17 halves. 5 and 1/2 is the same as 11 halves. Use the fraction multiplication algorithm, multiplying your numerators together to get 187, then multiplying your denominators together to get 4. Then you divide the numerator by the denominator to rename the product as a mixed number. 187 divided by 4 equals 46 3/4 feet squared. Another strategy you might want to use, you could convert the dimensions to inches. Then multiply. First, we would take 8.5 feet. That would be 102 inches since I know that 12 inches are in 1 foot. 5.5 feet would equal 66 inches. So then I would take 102 inches, multiply that by 66 inches. That gives me a total of 6,732 square inches. I would convert this product back to square feet. 1 square foot equals 144 inches squared. 6,732, which is our total square inches for this rectangle, divided by that 144 gets me the area of my rectangle. If you want a more visual approach, you could partition the rectangle to show 8.5 units along one side and 5.5 units along the other side. We could then count the number of squares. We learned earlier in the week that square counting is a good way to find an area of a rectangle. There are 40 whole squares, 13 half squares, and 1 quarter square. That's a square that's a fourth of the size all the way around. Combine your half squares to make whole squares. Well, I know 12 halves gives me 6 wholes. 40 plus 6 equals 46. Then I could add the remaining half square that's left over along with the quarter square. 46 plus my 1/2 square plus my 1/4 square equals 46 3/4. So that means my area is 46 3/4 square feet. We know that the formula for finding area is length times width. This week, we have found the area of rectangles with fractional side lengths by tiling or covering the area without gaps or overlaps, and then counting the smaller squares. Today, we will use our understanding of fraction and mixed number multiplication to show that the area found by tiling is the same as the area found by applying the area formula. Think back to the math message that we just looked at. Imagine that it is a model of a kitchen floor. If I wanted to cover the kitchen floor with square foot tiles, how many tiles would I need? Since the tiles are square foot tiles, I would need 46 and 3/4 tiles because I know my area is 46 and 3/4 square feet. What does 3/4 of a tile mean though? How could I cover 3/4 of a square foot with a square foot tile? You would have to cut one tile into smaller parts. If it's 3/4 of a square foot, we need a smaller tile. If I do not want to cut any tiles, what size tiles should I use? Since both the length and width have a fraction of 1/2, you could split each square foot into 4 parts so that each tile measures 1/2 foot by 1/2 foot. If you take each square foot and split it into 4 parts, your kitchen floor would then look like this. This includes smaller tiles if you wanted to use tiles that are not 1 square foot each. So how many of those 1/2 foot by 1/2 foot tiles would I need to cover the entire kitchen floor? If you count the smaller squares along the length and width of the rectangle and multiply them, you would get 17 for the length times 11 tiles for the width. That gives us a total of 187 tiles. Since the smaller tiles fit in a unit square 4 times, you could multiply the area, which we already know, by 4 to find the number of smaller tiles needed. 46 and 3/4 times 4 equals 187. If you multiply that mixed number times the whole number using an area model, you would find that 187 tiles are needed. Remember, even though we now need 187 tiles, the actual area of the floor has not changed. Our area is still 46 and 3/4 square feet, but I'm not using square foot tiles, so I need more tiles because my tiles are smaller. The area of the floor was reported in square feet. We are now counting the tiles that are smaller than a square foot. How could we use the number of small tiles needed to cover the floor to confirm the area? Since 4 of the smaller tiles cover 1 square foot, we could divide the number of smaller tiles by 4. 187 tiles divided by 4, which is the number of tiles in a square foot, gets us our area of 46 and 3/4 square feet. Think about these two methods for finding the area of a rectangle. When might it make sense to think about tiles with fractional side lengths to find the area? We could think about tiles in real-world situations when it is easier to work with whole tiles or when we know the size of tiles. Sometimes, though, it might make sense to just multiply the fractional side lengths to find the area. This comes in handy when we just need to know the area in square units. At this time, you're going to try to complete Math Journal pages 240 and 241 on your own. You can use any method to solve. If you liked the tiling method better, you can use tiling. If you liked using the formula where you find the length times the width, you can use the formula. But remember your steps for multiplying mixed numbers. When you multiply mixed numbers, you can either use an area model or you can change them to improper fractions and multiply straight across. Pause the video now so that you have an opportunity to complete these Math Journal pages. If you need some extra help on today's lesson, be sure to look at these student reference book pages. Remember, you can go back and look at these slides at a later time after the video. If you still would like a little extra help with multiplying mixed numbers, you could watch this video that kind of breaks down step by step how to use an area model when you need to multiply two mixed numbers together in order to find the area of a rectangle. Thank you, and please let your teacher know if you have any questions at all.